Hello students, welcome to Narayana online classes and online paper discussions. Today we are going to be discuss September 4th assignment, right, which is completely based on okay, stability in higher oxidation state. Higher oxidation state, this is the concept, we know that, right? So if it comes to the first question, the highest oxidation state of iron is stable in not only iron, any things, mostly D block elements are stable in the oxidation state with oxides. We know that four options are given. One is FeO and the second one is Fe2O3. Question number one, Fe2O3, and ferrate is also given, FeO4 minus 2 and FeF3. Don't forget that. Okay, iron is stable with oxides, but not with fluorides. So that's why option 4 is wrong, and it has less positive oxide, plus 2 and plus 3, and was it 4 to the 8 means plus 6, right? So that means least oxidation state and fluoride, both we can remove out, right? So but don't forget that FeO4 minus 2 is the ferrate, looking to be more highest oxidation state, but it is unstable. Reason, what's the reason? It undergoes reduction. It undergoes reduction to give again Fe2O3 and O2. Fe2O3 and half O2 it gives. So that means again it is giving Fe2O3. So that's why option 2 is correct. Option 2 is correct. If you observe the second question, which of the following oxocations are stable? So that was the meaning of oxocation. Along with oxygen it should be there. So but it should be in cation. Positive charge should be there. For example, if you observe the VO2 plus, what is the oxidation state of VO2 plus? X plus 2 into minus 2 is equal to plus 1. X is equal to plus 5. Means, okay, so vanadium is in plus 5 oxidation state, right? Okay, so that means first is correct. If we go for the second one, VO plus 2 is given. VO plus 2 means definitely X plus 1 into minus 2 is equal to 2. Again we are getting plus 4. That means vanadium, again we are getting plus 4. Yes, with oxygen it is stable. We are getting, right? In case of titanium also, when TiO plus 2 is given, here also we will get X is equal to plus 4. So that means titanium is in plus 4 oxidation state. So that's why. So all are correct. Hence fourth option is correct. Where if you observe the second question, okay. Then if you move for the third question, the highest stable oxidation state of manganese with fluorine. Don't forget that not only manganese, anything is stable with oxygen. Not with any other thing. So that the question, even though fluorine is the strong oxidizing agent, why the most of the metals, D block elements are stable with oxygen? Because oxygen can form multiple bonds where fluorine cannot form. So that means with one oxygen, valency 2 is possible. With one fluorine, only one valency is possible. So that's why with minimum surface area, most number of bonds are possible with oxygen. So that is the reason. So that's why with manganese highest. With fluorine, only MnF4 is possible. With oxygen, Mn2O7. That means it is plus 7. This is plus 4. So that's why MnF4 is answer. Okay, third option. So if it goes for the fourth option, if you move for the fourth question, the highest stable oxidation is over. So this is the fourth question. Sorry, this is the fourth question, right? The highest stable. It is third question. Third question given. So the fourth question, the highest stable oxidation state of manganese is, okay, highest stable oxidation state of manganese is Mn2O7. Now we got same thing, Mn2O7, because it got plus 7 oxidation state, which is equal to its group number. So don't forget that any maximum valency and maximum oxidation state of any element do not exceed its group number. We know that. Okay. If it comes to fifth question, If it comes to fifth question, the acidic, basic and amphoteric oxides of chromium. Acidic, basic, amphoteric. So don't forget that if one data I will give basic and amphoteric and acidic, right? If you observe these three. So for chromium, CrO will be there, Cr2O3 will be there, CrO3 will be there. For vanadium, V2O3 will be there, V2O5 will be there, or VO also we can write. So where acidic is not possible. If for Mn, manganese, MnO will be there, Mn2O3 will be there, Mn2O7 will be there. From this data, we will get the concept. Okay, say okay. Always low positive oxidation state. Okay, basic means low positive oxidation state. Acidic means high positive oxidation number, oxidation state. So this is moderate. So this is the information is given. So that's why the question is there. So according to the acidic, what is the acidic of chromium? Acidic of chromium is CrO3. So after acidic, basic CrO and amphoteric is Cr2O3. Hence key 1 is correct. Option 1 is correct. So that's the thing we have to remember. If it comes to the question number 6, V2O5, what's the specialty of V2O5? We can say one thing, the specialty of V2O5 over here is V2O5 is amphoteric, but it is mainly acidic. So what's the meaning of amphoteric? It has to show equal acidic and basic properties, but V2O5, okay, V2O5 is amphoteric, but acidic nature, but mainly acidic in nature, so that's why. So was the option, maybe the fourth option is correct. Option 4 is correct. If it comes to the question number 7, the amphoteric oxide of manganese. Just look at the data what I am given over there. So that's why amphoteric oxide is nothing but okay, Mn2O3, where we know that Mn2O7 is acidic. So this is nothing but amphoteric, where MnO is nothing but basic. So that's why amphoteric is given. Mn2O3 means option 2 is correct. If it comes to the question number 8, oxidation state of iron in FeCO taken 5. Don't forget that FeCO taken 5 is given. We know that cobalt oxidation state, carbonyl oxidation state is 0. That means X plus 5 into 0 is equal to 0. X is equal to 0. That means iron oxidation state is 0. Hence, option 4 is correct. Option 4 is correct. If we comes to the question number 9, just look at here. When we comes to the question number 9, what the question is given? Among MnO, Mn2O3 and Mn2O7, the most covalent compound is. Simple thing. The positive charge on central atom is directly proportional to covalent nature. So how many compounds are given? Just look at here. MnO is given, and the second thing is Mn2O3 is given, and the third one is Mn2O7 is given. Don't forget that plus 2 plus 3 plus 7. More positive charge, more covalent nature. More positive charge and more covalent nature. So less positive charge and less covalent in nature. So that's why option, which option is correct among MnO, Mn2, Mn2O7. So third option is correct. Option 3 is correct for this. What about last one? Option B. Option 10, if question number 10, among the 6th B group elements, the stable compound is. First only we have to take 6th B group. What is, okay, which elements are there in 6th B? 6th B, just look at your 10th question. 6th B means chromium, molybdenum, tungsten. Okay, so down the group, okay, in D block, the higher oxidation state stabilizes. So if it shows, if these three shows plus 6 oxidation state, because it is 6th be highest oxidation state plus 6, down the group highest oxidation state stabilizes. That means comparing to plus 6, molybdenum plus 6 is stable. Comparing to molybdenum, tungsten plus 6 is stable. So that's why tungsten plus 6 means WO3, where it shows plus 6. Okay, plus 6. So that's why key option 1 is correct. Option 1 is correct. Okay, that's all for today. This is assignment.